Now that we know the process for finding the multiplicative inverse of a matrix, let's just get some more practice. So here we go. We're going to start by taking our matrix, find 5 in the first column, 7, 3, and appending that identity matrix on the right side. And now I just need to do row operations. I am going to omit them just for time purposes. So again, I want a 1 here, so that'd be 7/9, and 1/9 here, 0, okay. So divide the first row by 9, and then I'm going to take -5 row 1 plus 9 row 2, or vice versa, but you end up with 0 there, -5, so -35 plus 27 is -8. Yep. Actually, I'm going to make that +8 just for ease, and then so that'd be 5. Yeah, 5. So I multiply first row by 5, second row by 9. So then I get 5 and -9. Okay. Okay, I'm going to take the second row and divide it by 8. So 7/9, 0, 1, 1/9, 0, and then 5/8, -9/8. Okay, and then lastly, I'm going to multiply row 2 by -7/9 and add it to row 1. So then I'm going to get the identity on the left. Okay, and then I need to take this times 7/8 and add it, or -7/9. And when I do that, I get, okay, so the second row would actually stay the same. So this is 5/8, and this is -9/8. Okay, in row 1 then, we would get -3/8 and 7/8. Okay, so that means that this matrix here is the inverse of A. So A inverse is the matrix that is -3/8 and then 5/8 in the first column. Second column is 7/8 and -9/8. Okay, boom. Okay, so fun? Question mark? Let's get some more practice. So here's B. Okay, so what I'm going to do is I'm going to take the matrix. We now have 3 by 3, so our work is going to be a little bit more complicated. Well, longer. Okay, I won't say complicated necessarily because the process is overall the same. 1, 10, 6, and then 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so now this, I think, from this point, I'm going to say we know how to do Gauss-Jordan elimination, and rather than me talking you through all of the different steps, I want you to try it. Here I did the first step of making or multiplying the first row by -1/2 and putting that into row 1. Okay, but I want you to go through the steps of Gauss-Jordan elimination and get it so that you see the identity matrix on the left-hand side of the equation. Resume the video when you're ready to see the steps. That I took, at least. And here you go. Okay, so that means that the matrix that is on the right here, this 4 minus 11, 53 over 3, etc., this is your inverse matrix, B inverse. Okay, so you can study the different row operations I did. You could have done them in a different order, and that would have been okay and arrived at the same answer. But ultimately, you have to arrive at this answer for B inverse. Okay, this last one I'm going to leave as a challenge for you. So again, the process is overall the same. We would start with we would append the identity matrix to the left or to the right hand side of this thing. -17, -1, and then 1, 0, 0, 0, 1, 0, 0, 0, 1. And do row operations on this until we get our inverse popping out. Okay, I think something interesting happens in this one. I believe that it is going to be non-singular. So I want you to try it out and resume the video when you want to start seeing some of the work. And so this is not the full solution, but it's enough of a solution. Once you get two rows of a matrix that are effectively the same, again, you would do row operations to continue this, but what you would end up with is this last row that is a duplicate of one of them would just end up being 0, so you would have a redundant, because you have a redundant row, and then consequently, once that happens, you don't have an inverse anymore. Okay, so this is enough to say once you get one row being a multiple of another, that there is no inverse, and that consequently C is singular. Okay, singular is the language again that we use to say that the inverse doesn't exist. Okay, so these do take some time because you need to go through Gauss-Jordan elimination. Take that time, be careful along the way, and you'll be successful.